Hello, Lana. How do you do? I welcome you again to Manifested Online Classes. My name is James Kenyani, and we are going to proceed. Go ahead with our topic on longitudes and latitudes. Today, we are going to look at the relationship between the radius of big circles and the radius of small circles, where the radius of the big circles also happens to be the radius of the Earth. So the main objective is for the learner to get to know the relationship and use it later in calculations. So the objective is for the learner to identify the relationship of the radii of small circles and the radii of great circles. Before we continue, we have a friend here, the class globe, which looks like the Earth. So initially we found that all these meridians you see, all the longitudes, now we shall be saying the longitudes, all the meridians that talk of the longitudes are great circles. They are great circles. So if I'm looking at it again, it is the equator, which is another circle. So it's easy to say the only latitude that is a great circle is the equator. But all longitudes are great circles. All longitudes which we happen to know go through the North Pole and the South Pole are great circles. They are great circles. So to understand that, I'll still come and draw these. So learner, that will be the center of the circle. I'll have that as the center of the circle. That will be the center of my circle. So O will be the center. So I'll have a point A, which is on a certain longitude, which I don't know, a certain latitude. So he said all latitudes, all those parallel to the equator, all of them are what we call the small circle. So this is a point A. A point A, which happens to be on this latitude. There is a point A there, which is on that latitude. So if I draw a straight line here, and I call that R, learner, you realize that OR will be the radius of the Earth, and it will be appearing on the equator. It will be appearing on the equator. I can also draw a line, straight line, from the North Pole, to the South Pole. So this might confuse us. If we are looking at a plane, we'll be forced to draw a straight line. We shall use a plane so that we understand it. That's P. That's P. So in the previous lesson, we said that this, if you join these to O, this is the line of latitude. I call this theta. Since this latitude is parallel to the equator, learner, that latitude PA, you can say PA is parallel to OR, because all latitudes are parallel to the equator. All latitudes are parallel to the equator. And you realize there is OR, and this happens to represent a great circle, happens to represent the great circle. So OR is also the radius of the Earth. OR is equal to OA. OR is equals to OA. This OR, because this is still the same radius, it will be equal to OA, but OR is the radius of the Earth. So Lana, you realize it is the radius of the Earth. So it's true to write here R, and here OA is also R. And this angle PAO, angle OAP, angle OAP is equal to angle AOR. Lana, those are called alternate angles. Alternate angles. They should be equal. So there is a relationship we get there. There is this theta and R, and you'll get R is the radius of the small circle. So Lana, you realize R here is the radius of that small circle. OR is the radius of the great circle, which happens to be the equator. So you say OR is the Earth's radius, and R is the radius of the small circle. Is the radius of the small circle. So by trigonometry, you can say the relationship between R and R. You can say cosine theta will be equal to adjacent over hypotenuse, R over R. So from there you'll get that the small radius will be given by R times the cosine theta times the cosine theta times the cosine theta, where theta is the angle of latitude. Where theta is the angle of latitude. Theta is the angle of latitude. This angle here is the same as that, but that angle is still the angle of that latitude. So from there, hence, you can just write hence, the small radius R is equals to the big radius r, which happens to be the radius of the earth, times cosine theta. Theta, as you've seen, is the angle of latitude, So you finally say latitude radius r is equal to Earth's radius r times cosine theta, where theta is the latitude angle. So learner, note that you can talk of any angle. You can vary that angle as much as you want. Like if I vary that angle up to there, you'll find the angle could have increased more than theta. So you'll find if I move here, the radius is a bit bigger. So it will be that small angle. To get that small radius there, it will still be the big radius, the radius of the earth, multiplied by the angle, the cosine of the angle. I'll get there. That happens for all lines of latitude. That happens to all lines of latitude. And number one, the radius of all big circles is equivalent to the radius of the earth. The radius of all big circles is equivalent to the radius of the earth. It is equivalent to the radius of the earth. So learner, this is the relationship between any radius of any latitude, any parallel to the equator, any latitude. This will be the relationship. Whether it is here, there, you take that angle because the angle varies. Here, maybe if it is 70, here it will be 60, 50, 40, until you get 10 as you move towards the equator. That will always be the relationship. To get the radius of that small circle, it will be the radius of the earth times the cosine of that angle of latitude. It's going to help you as when we are getting distances around or on latitudes or small circles. Having gotten that, learner, note that when they tell you that derive the relationship between the radius of the great circles and small circles, they are actually trying to tell you to do just what we've done there. You relate the big R to the radius of the small circle. Number 2. So there goes the question. They are relating it to a classroom globe. So in number 2 and number 3, you'll assume that the big R, learner, they are now relating it to this. We are coming down here. We are not on the earth. They are assuming that the big radius now is 18 centimeters. So it's a matter of substituting that radius of the class globe here. But note that when we come to the earth, we shall be using a bigger radius to calculate the radius of the small circles on the Earth's globe. So they have given you for the class globes so that you get enough practice before we come to that. So you'll take this radius of this class globe to be 18 centimeters. 18 centimeters, and you'll work out because you know the cosine of 45. You'll substitute it here. You'll substitute it there. So the value of big R in 2, 3 will be 18 on the class globe. But when you come to calculating actual distances on the Earth's surface, the radius will be bigger. It is going to be something around 6,370 kilometers. So thank you very much. Work out through that from the derivation, get the solutions, and let's meet in the next lesson. Bye-bye.